All infrastructure, whether it's an electrical grid, pipes, pumps, valves, dams, levees, rail networks, road networks, they have a useful life designed usually for anywhere from 25 to 50 years. Managing, maintaining, and operating them safely for all of humankind and for the nation is really critical.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor with Pumps and Systems magazine. Today we're speaking with James Perry, Executive Vice President of ASTERRA. He's going to be telling us all about aging infrastructure, specifically aging water systems, and what role technology plays in identifying problems to make a safer and more sustainable world. So without any further ado, let's get into the episode. Welcome to the Pumps and Systems podcast. We really appreciate you being here. So, how are you doing today?
Oh, wonderful. Thank you so much, Tom. And thank you for inviting me. I'm excited to speak with you today.
Yeah, absolutely. We're very glad to have you. So today we're going to be talking about aging infrastructure,
Mm.
specifically as it relates to water systems. But before we get into that, would you mind introducing yourself? So tell us a little about who you are, what you do, anything you would like our listeners and viewers to know.
Well, for me, it goes back to my experiences, and without it over being a me conversation, I just always enjoyed being around new technologies, disruptive innovation, trying to solve challenges in the world from a different angle. And I've been fortunate enough to do that cross-functionally. I worked for Hewlett-Packard for about 17 years, and always around bringing new ideas to market through HP Labs, and that's how I found my current company, ASTERRA, in a disruptive technology for a market that has great demand and need to solve problems uniquely.
So, of course, aging infrastructure is a really critical issue these days. But before we discuss it in more depth, would you be able to give us the basics? So, what exactly are we talking about when we talk about aging infrastructure? What all falls into that category?
What we noticed in doing market surveys was that all infrastructure, whether it's an electrical grid, whether it's pipes, pumps, valves, dams, levees, rail networks, road networks, they have a useful life designed usually for anywhere from 25 to 50 years. And most of our infrastructure goes back to the early 1900s. And we've just been past the useful life of all this infrastructure, and it's just far too expensive to replace all at once. And so managing, maintaining, and operating them safely for all of humankind and for the nation is really critical.
Digging a little deeper, what are some of the most critical risks that cities and utilities need to address when it comes to aging infrastructure and preventing failures and things like that?
Number one in my mind is really around safe delivery of drinking water. We need water. Some would argue, is it a basic human right or not? I do happen to believe that it is, but there is a cost associated with being able to have reliable, safe, and regular drinking water. And so it really starts there. And beyond that, into other infrastructure areas, it's about human safety. Failing dams can cost human life and do quite a bit. So making sure that we understand the sources of water through storing water to providing it safely and effectively to humans, to all of us, is really critical.
So, then what kind of technologies can help us identify problems in aging water systems and hopefully solve those problems before they get too serious?
Yeah, you see it quite a bit in the early stages. I've been in cities across the country, believe it or not, that still have wooden pipes delivering water below ground. After wooden pipes obviously had a very short lifespan, it was moved over to various types of metals, which are fine. There were safety issues with certain toxic metal types back in the day that have been tried to be replaced. and lead pipes and that kind of thing. So there was a constant growth to develop cost-effective and reliable solutions into PVCs and other types of piping materials. From then, they simply age out over time and various pressures and various ways they're breaking down. And that's where new technologies need to help support where new technologies coming in on maybe a pipe material. Now you need to be able to ensure that they're not breaking with greater frequency, and we know there are. And because you can't simply dig it all up and replace it all in one fell swoop, you need to have active ways to see below ground to be able to manage, excuse me, and maintain that infrastructure.
So, are there any barriers to adopting new technologies like that into infrastructure management? And if so, how do you think we can overcome those barriers?
Yeah, and when you're bringing in these new technologies, often the engineering systems and the operations people don't have time to waste trying to deal with science projects. They need regular reliability, understanding of the technology and what it will bring and what problems it's solving. It's really important to field test, field verify these things, not only from a provider of new technologies, but third-party independent engineering firms that can regularly and reliably describe what the problem and solution and new technology is solving. And then it's really all about making the market aware and adoption begins.
And can you tell us anything more about these technologies and how they work?
From our perspective, more and more you're starting to see the use of Earth observation technologies. There are something in the order of 6,000 or so satellites, ranging from a couple hundred miles to 500 or so miles above the Earth's surface. In the past, they were used for communication, military applications, academic applications, and now you're starting to see highly specialized radar that has very distinct capabilities to be able to look at the surface or below the surface for assets and infrastructure that maybe weren't even mapped a couple of decades ago. So finding those, monitoring those, maintaining those, it really is the strength of Earth observation satellites and radar specifically.
These days, we're seeing more and more extreme climate events like hurricanes and droughts. So, what kind of impact are those events having on infrastructure operators? And how can we make things better on that front?
As much as water is important for human survivability, water can also be the bane to an engineer. Most failure is dramatically caused in some way, shape, or form by water, unseen water that's moving, forcing ground changes and deformation, which impacts the infrastructure that's below it. So as we've seen climate change, global warming, the severity and frequency of big weather events, it's having a dramatic impact, and it's speeding up the failure rates and as well shortening the useful life cycle of the infrastructure below ground.
The goal here, of course, is to accelerate the modernization of aging infrastructure and ensure that it has long-term sustainability, reliability. So, is there a way that public and private sectors can come together on that, in your opinion?
There are many of the associations that support infrastructure, whether it's rail networks, drinking water networks, dams and levee networks. The federal government is engaged quite actively in ensuring that new technologies are brought to the forefront. So at associations, there's often opportunities to provide abstracts, white papers, case studies to understand what exactly a new technology is, how to best use it, where to best use it, so that you're able to maintain this infrastructure for a longer period of time. And it also helps guide where, if you think of the multiple trillions of dollars of infrastructure funding that's coming from the government, you need to know where to go first. Where is the consequence of failure and the likelihood of failure? And so new technologies can really hone down to more effectively and efficiently use those precious dollars on our precious resources.
Are there any specific examples or real life stories you would like to share with us? about this topic.
Yeah, do you know if you're thinking about the adoption of new technology and it's starting with science, call it a science project if you like. Our particular technology it began as a grant from NASA looking for water on Mars. Knowing that water wouldn't be at the surface, it would be below the surface. You needed a subsurface penetrating capability, which is the case of radar and satellites that can travel long distances. And so the example of taking this NASA basic grant, finding frozen lakes on the Martian poles, is just one example of how a new technology can solve a challenge, a clear challenge of not being able to see below ground in those distances. The next case was, well, how good is it going to be for humankind? So to be able to essentially turn those satellites around and use L-band synthetic aperture radar, that radar is able to go through these weather events, rain, sleet, snow, a tree canopy, vegetation, and then penetrate below ground, roughly 10 to 15 feet reflecting off water. And then if you can adopt an algorithm that could tell you what that water chemistry is, now you're able to see the assumption is if you're seeing drinking water below ground, it must have come from a leaking pipe. So that example, overlaying those pipe layers tells you where to go as pipes are leaking at a greater rate. You simply just can't wait for them to surface, nor can you find all of them. So you really need a tool that will be able to more efficiently point these operators and the system managers to the right locations to fix it. So that's a clear example of a public and private marriage, if you will, on adopting a new technology regularly and reliably.
So, what can you tell us about sustainability?
Adopting new technologies really is going to have multiple impact. So in the example of using L-band synthetic aperture radar, you've solved one problem around ensuring that these pipes and knowing where leaks are to maintain them is solved. But there's also a dramatic impact beyond that. One is the best source of new water is the water you already have, but it happened to leak through a pipe. It didn't get to its intended source. So by fixing and repairing those leaks, now you're making sure to take the impact of not only lost water, but remember, as an example, in the state of California, 20% of all the power generated goes towards water management and essentially pushing water. So if it's leaking, and you're using electricity to pump that, you're saving greenhouse gases by reducing emissions, by reducing the need and demands on additional electrical power sources. So we're very proud to take sustainability. It's something that all of us wake up in the morning and are really pleased to think about, that we're doing our part to reduce greenhouse gases, CO2 emissions, and recovering lost water.
All right. So, before we wrap things up, is there anything else you would like to share or any final thoughts you'd like to leave us with?
Well, I think the key to solving this infrastructure challenge that we have is really the private and public sector working together. Often funding is very difficult to come by. It's not easy to raise water rates or tolls, and so we need to make sure that these partnerships are sponsored and funded in packs within the federal government, state and local governments, as well as from the private sector. We invest all of our funds back into infrastructure development, and that partnership is really key on solving the challenges around maintaining and updating infrastructure systems.
All right. Well, thank you so much for taking the time to speak with us. We really appreciate it.
I'm glad to be here, and thank you for allowing me to share my thoughts.
Huge thanks to James Perry for taking the time to speak with us today about aging water systems. If you're listening to the podcast and would like the chance to watch it, head over to our YouTube channel to see the full video version. That's going to do it for this episode. Thank you so much for listening or watching, and we will see you next time.